Hello everyone. In this video we will get started with Brigade. First of all, you will need a Kubernetes cluster. You can use any cloud provided cluster or a local one. In this case I'm using Docker Desktop with a single node cluster. Everything you're about to see can be found on the documentation website for Brigade. And to get started, we will deploy Brigade in our cluster using Helm. I'm using Helm 3 to deploy Brigade to its own namespace. And at this point, we can start using the Brigade CLI, which can be downloaded from the release page on GitHub, and run brig check, which makes sure that all of Brigade's components are properly deployed in our cluster and are running. So we can see an API server, a controller which is listening for events, and an optional web dashboard. And now we are ready to start writing Brigade scripts. What I did previously, I created a Brigade project, which is just a logical grouping for data secrets and things like that. So I didn't have to create it right now. It's called Hello KubeCon, and we will reference it when generating events through the Brig CLI. So the simplest Brigade script requires us to import Brigadier, which is the JavaScript API for Brigade. Specifically, we're using the events and job objects, which we will see throughout the examples in this video. Brigade is an event-driven scripting engine on top of Kubernetes. So every entry point in a Brigade script is an event handler. In this case, we're reacting to an event called exec, and we're reacting by executing this particular function. So what this function does is every time there's an exec event, we create a new job called do nothing based on an Alpine container, and we execute the following two jobs, echo hello and echo world, and then we run it. And we can use brig to generate an exec event, which the script and the controller are listening for. And we're passing the name of the project that we saw earlier and the name of the script file that we want to execute. If this was a real world scenario, the Brigade.js file would be somewhere in a GitHub repo, and the event itself would be generated by an external system. And right now, the Brigade worker executed our script, and we can start inspecting what happened in our cluster. Brigade offers multiple ways of seeing what's happening in a cluster. First of all, we have a web dashboard that I mentioned earlier. And brig dashboard is a CLI command that tunnels traffic from your machine to inside a cluster using port forwarding. And you can see the name of the project. There was an event from the Brigade CLI called exec that ran a few seconds ago, and there's a job called do nothing, and if we click on it, we see the logs for our jobs. If you're not familiar with it or don't have access to a web dashboard or browser in your environment, you can also use a CLI dashboard built by the community. There's a brig term command that starts this dashboard, and you can see the same sorts of information but in a terminal dashboard. As well, you can see the logs, type of job, source, and everything else. Of course, you can create multiple job objects and run them in the same way. But Brigade also offers you a way of grouping multiple jobs. So imagine if you have lots and lots of jobs and you want to schedule and orchestrate their execution. Brigade offers an API called groups, and one of the methods on the group object is run each, which makes sure that your jobs are run sequentially. So hello is started, its execution is finished, and then goodbye is started. So if we executed this Brigade script, we would expect that hello to start and finish, and then goodbye to be executed. And brig term also offers a very nice visual representation of the pipeline invocation and execution. And here you can see Brigade started, and then after it finished, the goodbye job was started. So, and the logs as well. Because this is plain JavaScript, you also have multiple ways of making sure you can await certain operations. The run function returns a JavaScript native promise. So if you're familiar with the async await functionality in JavaScript, you can also use that as well. If you're not, if you're more familiar with grouping API, you can just use that. Brigade also offers a very simple way of dealing with storage in Kubernetes. There's an object called storage that you can enable or disable per job. And if you enable storage for jobs in your event execution, the Brigade worker will create a persistent volume and attach it to each of these jobs that require it. So if we run this, what we expect to happen is the persistent volume will be mounted on Mount Brigade share by default. You can change that, of course. The first two jobs will write in the file, and the third job will print the content of the file. So if we go to Brigade term, and the first one wrote into the file, the second one wrote as well, and the third job printed the contents of the particular file. Again, what this does is it creates persistent volume storages, it attaches them to each of the jobs sequentially, and then deletes them at the end of the execution. Keep in mind that the storage is volatile, so it's deleted at the end of the execution. But it's a very simple way of attaching storage to event executions. There's also another type of storage that Brigade surfaces in its API called a cache. The build storage is storage per event. So on every new exec event, Brigade will create a new persistent volume and it will attach it to each of these jobs. In the case of a cache, it's the persistent volume survives multiple invocations of the same event type. So every time there's a new exec event and the new cacher job, it's by the name of the job and container, the same persistent volume will be attached. And you can use that to, for example, build caches, compiler caches, and things like that. So if we execute this particular script multiple times, we expect the same persistent volume to be attached to this job and us to be able to write across multiple event executions. So you can see if we run it again, it will append to that particular file and the same storage will be attached again. So you can see it was attached again. Another type of interesting thing we can do with Brigade is get results out of job executions. Particularly, standard output is one of the things we can get out of event executions. And here you can see another way of waiting for jobs. You can use the thenable syntax in JavaScript. Is the same sort of result as you would get with awaiting job runs. But specifically, we start a new job called one. We wait for it to finish. We grab its result, which is the standard output, and use it as input for job number 2 and use it to echo whatever the input was. So if we execute this, what we would expect to happen is job 1 to start and finish, its standard output captured by Brigade and used as input for job number 2. And if we look at this, we can see job 1 started, it finished, and then job 2 exited, and we can see the output for the first one used as input for the second one, which is rather difficult to do if you don't have a way of capturing output with a real programming language. The final thing I want to show you with a real programming language is handling errors and ways to handle cleanup, for example, if something goes wrong. We have a first job that will exit successfully, and the second one which exits with an error code every time. What we want to do is make sure that we catch any sort of exceptions in in the execution and make sure to clean up, do some other operations if it fails. So if we execute this, we expect the second job to fail, but only the job. The execution of the script itself will continue, and we can continue to execute code that does, for example, cleanup. And as expected, it failed to run to completion, but the second job failed. But if we have a look at the logs for the worker itself, we can see that the execution continued, and we could have done other things as well. This is just these are a few things that you can do with Brigade. For a complete guide, I recommend you check out the Brigade documentation. Everything you've seen here is detailed and described here, together with many more examples. Thanks. Enjoy your conference.